Alright guys, so continuing on here, uh, second part of this says to determine if a root exists over the interval a to b. So determine if a root exists. Let's go ahead and label this part I, just like they have up here. To determine if a root exists, you pick your two numbers in your interval. So first you need to figure out what f of 1 is. You need to figure out what f of 2 is. Alright, now if you plug in a 1 in here, you're going to get 4 minus 6 plus 3 minus 2. So 4 minus 6 is negative 2 plus 3 is positive 1 minus 2. You get negative 1. Now if you plug a 2 in here, you get 2 cubed, which is 8, times 4 minus 6x squared, so minus 12 or minus 24 plus 6 minus 2. Just for the sake of time, that's 12. Alright, so what you notice here is we go from a negative to a positive on our interval. So just like we said before, once you go from a negative to a positive, that tells you you have a sign change. So I'm going to write here, because of a sign change, there must be a root. There must be a root. So because of a sign change, there must be a root. So we have proven now that there is in fact a root, and now they want us to figure out what is f of c, or where is f of c 10 rather. They want us to figure out what c is. So what we're going to do here is set our equation. We have I. Personally, these equations are a little bit much for a non-calculator test, so on the actual test they will be a little bit easier to plug in and manipulate. So we set our y value equal to 10. Solve for your answer. Now in this case it happens to be 1.922, rounding out to 3 decimal places. Okay, so that's example 2. Example 3. Again, very first thing says to determine if f of x is continuous over a to b. Now right off the bat, there's a few things I want to point out here with example 2. Right off the bat, something kicks me in the face, and it says that we have an issue with our denominator. We have an issue with this denominator, and that issue is that the denominator cannot be 0. So right off the bat, I know something is going to happen when this bottom part hits 0. So here's what I would write. First off, where does this equal 0? What happens when x is negative 3? Well, that's fantastic and all, but what's our interval? Our interval is negative 2 to 25. Negative 2 to 25, and this is negative 3. That's outside of our interval. So I want to write this down real quick for I. F of negative 3. F of negative 3 is a problem. However, it is not in our interval. Alright. F of 3, negative 3, is an issue because it'll make the bottom 0. However, it's not in our interval. It's kind of like we cut off the piece that makes this thing undefined. As a result of that, f of c exists, right? The limit as x approaches c of f of x exists, and f of c is equal to the limit as x approaches c of f of x. Because of all this, we can say, therefore it's continuous over the interval negative 2 to 25. Okay, so again, you see what I did there. I looked for a place where it could be discontinuous. Here we have an asymptote at negative 3. I look at that and I say, is that in my interval? In this case, it is not. It's outside of my interval. So because it's outside of my interval, I can have a continuous function. All right. I. So then we verify that it has a root. So we take f of -2. And f of -2 is going to be, where we put a -2 in here, we get a -4/1, so -4. F of 25, 25 minus 2 is 23, 25 plus 3 is 28. So it is 23/28. Now what's important here is that it is positive and negative. The numbers themselves aren't really that important, but what is important is that we have a sign. Let me get this over here. A sign change. Therefore, a root exists. All right, we have a sign change. Therefore, a root exists. Next step here. Set our x minus 2 over x plus 3 equal to 0.8. Solve that out. Now, when you multiply this over here, you'll have to distribute the 0.8. Solve for x, get all your x's on one side, blah, blah, blah. Anyway, you come up with x, which is c, is equal to 22. Back over here, I wrote c is equal to 22. Keep in mind that this is your x value. All right, you're looking for c, some constant you can put in there to actually make this thing come to pass. All right, because remember, c and k is what we're looking at now, not necessarily x and y, but it's c and k. All right. Last one here, example 4, says the function f is continuous on the closed interval 0 to 2, has values that are given in the table. So here's your values from 0 to 2. 1, k, and 2. Notice they have a k here instead of an actual value at 1. It says the equation f of x equals 1/2 must have at least 2 solutions in the interval 0 to 2 if k, fill in the blank. The equation f of x equals 1/2 must have at least 2 solutions in the interval 0 to 2. Okay, so here's what I want you to do. Let's draw a quick graph. If y'all can hear Mr. Jeter, I apologize. He's out there yelling again. Alright, and all I'm going to do, let me do this a little bit wider here. All I'm going to do here is plot the points that I do have. So I've got 0, 1, and I've got 2, 2. And then look at what it's actually saying here. It says that the equation f of x equals 1/2. F of x is equal to 1/2 is right here. Must have at least 2 solutions on the interval 0 to 2 if k is equal to what? They're saying, what can you put into k here at 1 to absolutely guarantee that you are going to have 2 solutions? You got 5 choices here. So think about this. If you put in 3, if it's up here, way up here, and it goes like, and this function connects those 3 dots, how many times is it going to cross this line down here between 0 and 2? It's not going to cross any. If you put it at 2, it's still not going to cross any. If you put it at 1, it's still not going to cross any. If you put it at 1/2, see, now it's going to cross, but it's only going to hit once. What I'm saying is that if you were to draw a parabola, or not a parabola, excuse me, but a curve, connecting those 3 points, something like that. You see how that would only hit once if your point was 1 comma k? And it's asking you, what does it have to do to have at least 2 solutions? What does k have to be to have at least 2 solutions? Well, it's got to be 0. Check this out. If you were to go down and hit 0 and then come up again, how many times will those 2 graphs cross? How many solutions will you have? You'll have 2 solutions. So in this case, k has to be 0.